BTL presents an innovative therapy, the superinductive system. The basis of the whole technology is the high-intensity electromagnetic field created in the applicator coil. Based on the frequency and intensity of this field, the device causes pain relief in the first place, and also joint mobilization, bone fracture healing support, trigger muscle contractions, or achieves muscle relaxation. The analgesic effect is reached through affecting 3 different theories of pain. At lower frequencies in the range of 2 to 10 Hz, the superinductive system affects tissue through the endogenous opioid theory of pain. The gate control theory of pain is affected using frequencies of 60 to 100 Hz. 120 to 140 Hz frequencies suppresses pain through the coding theory. Due to the versatility of the BTL superinductive system, analgesia is the key effect and its main asset in the treatment of musculoskeletal and neurological disorders. Another medical effect caused by the BTL superinductive system is joint mobilization, which occurs due to repetitive muscle contractions in the articular capsule area. The contractions cause a slight shift of the joint surface against each other and as a result release the blockage and restore joint play. Muscle contractions are used in the strengthening of weakened muscles and muscle groups and in preventing muscle atrophy. The contractions are achieved by stimulating the neuromuscular tissue. The therapy is contactless and it's therefore easy to treat various body parts. The BTL superinductive system can also support the bone fracture healing process. Through action of the high-intensity magnetic field, neovascularization occurs in the area, and through that, new bone formation is supported. The superinductive system positively affects spasticity disorders. The therapy procedure then consists of reciprocal inhibition of the spastic muscle and facilitation of the antagonistic muscle, which leads to spasticity reduction. An electromagnetic field is targeted into a small spot right in the center of the coil in the focused applicator. It penetrates deep into the tissue, which allows for precise targeting of the therapy, which is particularly important in the treatment of neurological disorders and pain reduction. Examine the patient thoroughly to find the disorder and the location to be treated. Thanks to the variable 6-joint arm, the applicator is easily placed above any body part. Select the suitable preset protocol according to the defined disorder from the device encyclopedia and press Start. After starting the therapy, adjust the intensity to the recommended level using the knob on the device. Communicate with the patient while doing so in order to set the intensity precisely. From this point, the therapy runs without the need for the therapist's intervention. The treatment continues until the therapy time is up. High-intensity laser is a device which produces coherent light of one or more specific wavelengths. A laser beam carries energy which spreads through the tissue and can be used to treat inflamed, torn, or otherwise damaged or infected tissue, in which it speeds up healing, recovery, and reduces pain. High-intensity laser penetrates the skin uninvasively and spreads further into the subcutaneous fat, muscle, tendon, and bone tissue, depending on the location of the treated area. The process through which laser heals the damaged tissue is called photobiostimulation. Upon application of laser light on human tissue, there are 4 different effects that occur. Reflection, the light doesn't penetrate the tissue. Scattering, the light is distributed randomly in the tissue. Absorption, the light is absorbed by the molecules of the tissue. And transmission, the light is transferred deeper into the tissue structures, being absorbed eventually. There are 3 key effects of therapeutic high-intensity laser: photoacoustic, biostimulation, and thermic. Human tissue is composed of various components, of which the most important for laser irradiation are water, hemoglobin, and melanin. Their absorption, as well as the scatter coefficient, are different for different wavelengths. The optimum scatter to absorption ratio of 1064 nanometer wavelength makes it ideal for deep tissue penetration. A 1064 nanometer high-intensity laser beam can reach up to 10 centimeters deep into the tissue. One of the key effects induced by the 1064 nanometer high-intensity laser beam is the photoacoustic effect. Photoacoustic waves are created when the area is irradiated by using very short pulses with a high repetition rate. Such mechanical waves stimulate free nerve endings in the tissue and cause nearly instantaneous pain relief in the area. Biostimulation, in other words, stimulating the organism on the cellular level to enhance healing and recovery with a 1064 nanometer laser beam, is another key effect of the high-intensity laser. Oxygen is processed in cells by mitochondria. Here, oxygen is processed by a cascade of respiratory enzymes and delivered to ATP synthase, which synthesizes the organism's source of energy, ATP. A faster exchange of oxygen and metabolites due to laser irradiation causes more oxygen atoms to reach mitochondria. Mitochondria are further stimulated to synthesize ATP faster by laser irradiation at 1064 nanometers. ATP allows for faster synthesis of RNA and DNA and leads to faster recovery, healing, and edema reduction in the treated area. The thermic effect of high-intensity laser therapy is caused by absorption of the 1064 nanometer laser beam in the superficial structures, which consequently causes temperature increase in the tissue. The thermic effect also causes vasodilation. As a consequence, blood perfusion increases, larger amounts of oxygen are delivered to the tissue, and more metabolites are resorbed.